Hi everyone. This is Team 5 from the course Big Data Intelligence and Analytics. I am here with my teammates Sanya Kapoor and Anamika Bharali, and we will be demoing our final project, that is Shakespearify, an AI animator tool. So let me take you through a bit more detail about our project. Okay, so basically what our project is about is there are a lot of plays and a lot of texts that is ancient and yet hold a lot of culture. So our goal was to basically generate an image and make the old text more attractive so that it could be reached to a more younger crowd and people in today's generation. We have extracted a few of Shakespeare's plays to begin with, and also we have a feature of uploading an EPUB file. So if the user wants to create, if the user wants to see illustration of their favorite storybooks, they can do that. Let me take you through the demo of our app. So here are a few of the plays of Shakespeare that we have illustrated. So you can see here is a small information about the what is happening in the picture, and this information is a continuous flow so that someone who is reading could understand the entire story. All of these images are generated using Stable Diffusion API. We also give an option of uploading files, EPUB files. So let's upload one. Let's go with Alice in Wonderland. And once the file is uploaded, the chapters are extracted from it, and you can select any chapter that you want to see illustrated. Yes. So here you can see the chapter 3 of Alice in Wonderland has been converted into an illustration from EPUB file. Now, we can also make some changes to the art style and the image style according to our like. So for example, for that we need to just take the text below it and put it here in the prompt, and then we can just make some choices of our own. Thus, like the parameters like steps, CFG, scale, and seeds are basically used in Stable Diffusion to make the images more better and more consistent. So if we select this, and if we select, like for example, maybe neon punk, then we will expect our first image that was generated above to change, like here it is. And let's try something else, maybe line art. So here you can see this has been changed into a different image. So user has the liberty of changing the art style as he likes. So for going into further details of the project, I would like to hand over it to Anamika.
Hello everyone. So I'll be going through the architecture diagram. So this is the executed architecture diagram. What we're doing is first we're data scraping using Beautiful Soup, and we're getting all the plays, 5 plays to be specific, by Shakespeare. We're taking that data, segmenting it into 4 parts, and saving those data chunks to Firestore. At the same time, for the functionality where a user can upload an EPUB file and do the same, I mean, see the illustrated images, we've made the second Airflow pipeline where we are uploading EPUB files, and it's going through the same thing, such as chunking them, a segmentation into 4 parts, and saving each segment to the GCP database. Both of these databases are being accessed by OpenAI to make tokens, which for to make prompts, which further is propagated to Stable Diffusion, which is using these prompts from. So there are 5 prompts for each segment, and there are 4 segments of each book or play. So these 20 prompts are making 20 images to make the illustrative diagrams, the comic strip, and these are saved in MongoDB and an S3 bucket, which is then communicated to Streamlit through Fast API and Heroku. So let's go on to the code where I'll go through the first pipeline. Okay, so as you can see, I'm data scraping here from this URL, the Gutenberg URL, which has all the plays by Shakespeare. And what I'm doing is I am splitting the whole content using the chapter names and using them as story names. This way we can segment the whole content, and then we are segmenting it into 4 chunks, which is then uploaded to Firestore. So as you can see here, there are 4 segments for each chapter. Moving on to the second pipeline, it's similar, where we are reading a file, and then we're moving on to segmenting it into 4 parts for each chapter. So here also we are looking for chapter names so that we can separate, and each chapter is being segmented into 4 parts. And moving on, it is being uploaded to Firestore. I'll hand it over to my teammate Sanya so that she can go on with this.
Hey, thank you so much, Anamika. I hope my screen is visible. Okay, so let me take you through the third pipeline. So as we know that the data is stored in Firestore in form of 4 segments, and now these segments are then pulled into the prompt engineering um, and prompt engineering function, and that's where OpenAI works its magic. It creates prompts from those chunks, and then it puts those prompts into our stability AI, and from that we get our images and prompts, which are then stored in the image, in S3 bucket. The images are stored in S3 bucket, and in MongoDB we are storing the URLs of the images that are stored in the S3 bucket along with the prompts. So I will show you what that looks like. So here's the data in the MongoDB. As you can see, we have the story name, alongside which we have the image name, and the URL it's fetching from S3 bucket, and here's the prompt that's generated. And I can show you the S3 bucket as well. Yeah. So all the URLs are stored here, and that's where the MongoDB calls it from. Also, I will show you what our Fast API looks like. Our Fast API is hosted on Heroku, and this is the Swagger AI. So this is the backend, and obviously you've seen the front end, that's Streamlit. Thank you so much for your attention.